So everyone, I'm sure on this call is aware that a significant challenge in multi-regional research is that data vary significantly across the country, and even data sets that appear to be the same, such as DAD or hospital discharge abstracts, can differ in terms of coding practices, inclusion rules, or even variable names and formats. So data harmonization reconciles these differences across the sources in terms of both their structure and meaning so that they can be more meaningfully compared. Next slide. So one of the main goals of the Harmonized Data and Tools team is to implement and evaluate approaches that support the creation of harmonized, research-ready data sets to enable more efficient and comparable multi-regional research. And the team's work is guided by several considerations or principles. The first being that we aim to be flexible and scalable, recognizing that there's not just one approach to harmonize data, and approaches need to support a growing number of data sets, different users, and different research needs. We are responsive to those different users, recognizing that the needs of researchers may vary from those of knowledge users, for example. We are aligned with the FAIR principles in open science, ensuring reusability, interoperability, and transparency. We really design for reuse such that you harmonize once and it can be used in repeated projects, but also such that the harmonization workflows or approaches can be reused and repurposed. And finally, and importantly, we remain respectful of the differences across the network in terms of the variation in technology, governance, and other local practices. Next slide, please. So there are two kind of key streams of work that Alice and I will briefly cover today. The first is around documenting differences across common data assets and domains. And the second, which Alison will speak to, is about implementing common data models, most notably the OMOP common data model. Next slide, please. Oh, you can. Next one, thanks. So documenting differences in data assets is really a foundational step in data harmonization. Like essentially, you cannot harmonize what you don't understand. And this work involves identifying what is comparable across data assets and what is fundamentally different. So we know these differences arise from how and when data are collected, the populations included, other local policies and practices. And it's important to understand and document these differences from the outset. Otherwise, what could look like harmonized data may not actually be comparable when it comes to analysis. Next slide, please. So the team, which is this work, is led by Sandra Peterson, and the team have begun documenting differences kind of in two areas. So the first being knackers and emergency department data, and the second is looking at diagnostic coding. So in terms of knackers and emergency department data, the sites have documented information on population coverage, the scope of the data set, notable gaps and changes over time, any data quality issues. And for diagnostic coding, we've looked at how these coding or the vocabularies are code or diagnostic vocabularies are coded in physician claims, DAD, and ED data. So looking at terminology used and changes in those terminologies, the number of digits, number of fields with diagnostic codes, and information like that. Next slide, please. So as you noted, the documentation is currently captured in spreadsheets, but sort of the next steps for this work is really making this information available in a reusable and accessible format, both internally to support projects and then also externally to make it work easier for researchers and other users to understand the data available across the network. This work also will directly support harmonization. by identifying kind of the commonly used variables across projects, not so much data sets, and then mapping how these variables differ across the sites, and then potentially developing crosswalk codes to standardize variables, such as renaming variables where feasible. And finally, this work will be expanded to other common data and data domains such as DAD, same-day surgery, and physician claims. So that's just a brief overview of some of the sort of preliminary harmonization work. And now I will pass it to Alison, who will be giving an overview of the common data model work.
Okay, thanks, Georgina. So I'm going to talk a little bit about just common data models in general, and then specifically our OMOP common data model piloting and next steps for what we're planning for OMOP. So common data models in general standardize data structure and formats, and they may standardize content and analytic tools as well. They create efficiencies that can increase the speed of individual projects across multiple sites while ensuring consistency within and across analyses. So HDRN Canada is adopting common data models as just one approach to harmonizing data to enable research across Canada. There are many different CDMs in existence. As you can see on the screen, there are some logos here. Each is developed for a specific purpose. Some are used internationally, like OMOP and I2B2, while others are more specific to certain jurisdictions, like CNODES, which is the Canadian Network for Observational Drug Effect Studies, which obviously is used within Canada. So because CDMs are developed for specific purposes, there's no one CDM that will meet the needs of all users. So for instance, Sentinel is optimized for post-market drug surveillance. PCORNet is optimized for patient-centered research. Both of these prioritize flexibility over standardization, however, which can make querying the data much more complex for an analyst. On the other hand, data in OMOP are highly standardized, primarily by using standardized ontologies such as SNOMED and RxNorm. This optimizes OMOP for computational efficiency, which allows an analyst to execute a single query across the entire network with little to no modification to that query. So HDRN Canada is interested in OMOP for a few different reasons. So OMOP, as I mentioned, is highly standardized. So it can enable more cost-effective, rapid, and reliable studies, especially when it comes to federated analyses. By harmonizing core data assets across HDRN sites, OMOP can facilitate collaboration and large-scale analytics more rapidly than if you were doing it just in your source data. OMOP has already been globally adopted, including in the US, the UK, EU, Asian countries, and increasingly in Latin American and African countries as well. It's also been adopted by some large cross-governmental agencies like FDA and EMA. So this would allow HDRN sites to easily start collaborating with international partners who are already using OMOP. And in addition, as we've come to discover, OMOP is increasingly being used within Canada, not necessarily within HDRN, but other organizations in Canada. So in terms of OMOP itself, OMOP is a person-centered relational database model where data about a person's encounters, clinical encounters, medications, procedures, and so on, are all stored in different linkable tables. And the current OMOP common data model is version 5.4. It consists of 39 tables, including 17 that are clinical. 5 are health or health economic tables, and then the remainder are supporting tables like the standardized vocabulary tables that are part of the common data model. In addition to the structure of data, the OMOP common data model standardizes the content of the data by enforcing standard vocabularies that vary according to domain. So as I mentioned already, 2 of the standard vocabularies are SNOMED, which is used in the condition domain, and RxNorm, which is used in the drug domain. Athena is the name of Odyssey's central web-based repository of vocabularies. You can just open it up at any time and search it if you want. You don't need an account, but it's also a place where you can download the vocabularies to then import them into your OMOP common data model. So it houses both the standard vocabularies as well as many non-standard vocabularies that have already been mapped to standard vocabularies. So for example, ICD-10 and ICD-10-CM, these would be considered non-standard, but mappings have also exist to map those to the standard concepts. So the Odyssey community has already done that, and you can access those through Athena. The Odyssey community also maintains many open source standard analytic tools that can be used for everything from data profiling and exploration to vocabulary mapping to very complex analyses as well. So this helps individuals to standardize not just the structure of their data, but how they go about analyzing the data as well. So in terms of our pilot, so HDRN Canada started to pilot the OMOP Common Data Model in late 2023. We started with 4 provincial and 1 pan-Canadian data centers. So that included Alberta, Manitoba, Ontario, as well as BC and Kaihai, who participated more as observers as opposed to actually implementing OMOP. So to evaluate the advantages and disadvantages of OMOP compared to usual practice, we selected an existing multi-jurisdictional study that was already underway for another project, and it was on spinal muscular atrophy, which is a rare genetic condition. So the reason we chose that use case was that it was a very well-defined, manageable cohort. It was relatively small. And approvals were already underway at the different data centers, which made it easier for us to just jump in and piggyback on those approvals. This figure shows the general workflow from how we started out, which was the ETL design and data exploration and data mapping, to the vocabulary mapping and actual implementation of the ETL to actually create the OMOP, Common Data Model database. And then each time tables were generated or updated, we had to go through quality control using something called Data Quality Dashboard. And then after that, once we were satisfied with our OMOP databases, we then ran the SMA use case replication to compare to the source results. So together, the different sites work together to define what source data and target OMOP tables to populate for this particular study. So the source data included provincial insurance registries, hospitalizations, physician and prescription claims, vital statistics, census-based information as well. And you can see that the different types of data fed into various different tables. So it wasn't that one table only, captured the registry information. Some of that information fed into many different tables. So we used all available years of data for the insurance registry and vital stats and census data that was at the different sites. However, when it came to the inpatient, outpatient, and drug data, we restricted our transformation to just SMA cases from 2004 to 2022. The reason for that is that it was much more complicated to convert that data due to changes over time in coding schemes and what fields were captured, and also the requirement for mapping diagnosis codes to standard codes would have been too much for us to handle sort of early on for the pilot project. So all the sites mapped their source data and fields to the relevant OMOP Common Data Model tables and fields. We collaborated by having weekly meetings and documenting our mappings in a shared Google spreadsheet. As you can see on the screen, there's a screenshot that shows site-specific data mapping for the OMOP person table. The columns that are in green are the Ontario information. The orange is Manitoba, and then you can't see there's Alberta and BC and Kaihai as well. This format allowed us to look at how each site was identifying and defining each particular field within a particular table so that we could check. It's sort of like a data quality check, and to see how one site is doing it in case you had questions about how you should do it at your site. You could see how, another site did it. So this really helped us to sort of to collaborate with each other. So the original SMA study involved 240 ICD-10-CA codes and 3 drug codes, which were DINs. So ICD-10-CA and DIN are not standard classifications in Odyssey. So they needed to be mapped to the standard concepts, like I had mentioned earlier. We leveraged existing ICD to SNOMED mappings whenever possible that we found in Athena. That worked for around 90% of ICD-10-CA codes, which were, these are codes that are equivalent to ICD-10 or ICD-10-CM. So we could use those mappings. The remaining 10% were Canadian specific, and we had to do custom mapping for those codes. We also leveraged advice from Kaihai and OMOP vocabulary experts when we were doing this. In addition to the diagnosis codes, we mapped 3 SMA-related drug codes, and they were mapped to RX norm. And something I just want to point out is that even though we only mapped 240 diagnosis codes and 3 drug codes, all of the source diagnosis and drug codes still remain within each OMOP table. So even if you didn't want to work with the standardized codes, you could still go back and work with the original ICD codes if you wanted to. You don't lose that information. It's just that you're adding standardized information on top of what is already in your data. And we used Odyssey's data quality dashboard tool to check the plausibility and conformance and completeness of each OMOP table. So each time we generated a new table or had to update a table, we went through this process to make sure that there weren't any glaring mistakes within those tables and that they were all sort of linking and communicating with each other properly. This is a screenshot that shows the data quality dashboard, or part of that dashboard, for the Ontario ICS OMOP database. For the SMA replication part, we first had to repeat the original SMA study after we had decided to make some minor revisions to the time frame. That was in order to make it consistent and comparable with what we were able to do in the OMOP transform data. So it was just basically some minor changes to the dates. And then for the OMOP replication, we leveraged Odyssey tools and packages whenever possible to define and generate the cohorts and to generate the descriptive statistics. The cohort definitions and analytic queries were first generated by in Ontario at ICS, and then that code, those queries, were then shared with the other sites to ensure consistencies, and they basically would just run the same code with some minor changes to point to their particular database. This helped us to be consistent and also to avoid duplicating effort. So in the end, the results were identical between the source and OMOP data. That said, this was a small descriptive study, and we know that larger, more complex studies are needed to fully assess the performance of OMOP and the efficiencies that could potentially be achieved with OMOP. But we do expect, with increased expertise, that the time to conduct analyses will be significantly reduced compared to when doing it in the source data. And then to summarize sort of our evaluation of findings, so obviously the OMOP common data model faithfully represented the source data in this particular use case, but there were a number of challenges that we ran into along the way. So including resource constraints, a steep learning curve, since none of us had used OMOP before, so it was all very new to us. Working with IT, getting our IT departments to have time and also to learn about the different software that needed to be installed, and also getting approvals through our legal and privacy departments. However, there were also many enablers, such as community support. There's a large network of Odyssey users, and they're always willing to answer questions in forums and help people out. There was a lot of collaboration between the sites. We discussed a lot of things and worked things out with each other. And lessons learned from this and the expertise gained will benefit future expansion and broader adoption at HDRN. That said, OMOP is not necessarily suitable for all data types and projects, but CDM extensions and modifications and potential collaboration with the Odyssey community may address some of the limitations. So, for example, the next version of the CDM, which is 5.5, will be coming out, I believe, this year. And that will incorporate a lot of feedback from the community. So each time they release a new model, it updates with new extensions and things that people have asked for. So there's an opportunity for us to promote the Canadian needs as well. There's a strong interest in adopting OMOP at HDRN, but the resource demands are always a concern. That's not just at HDRN, that's at all sites. It's always a lot of upfront work. And you have to find the time and the people that can actually dedicate their efforts to doing it. So in terms of beyond the pilot, talk about some of the expansion work. So since vocabulary mapping is a major aspect of converting to OMOP, most of our work since the pilot has focused on mapping Canadian diagnosis and drug codes to the Odyssey standard vocabularies. To help us do some of this, Canada's Drug Agency provided some limited funding for us to map some diabetes and contraception related codes, drug and diagnosis codes. These were codes that were related to their monitoring and evaluation framework for the PharmaCare Act. And so they were highly motivated to support some of this work. And then most recently, we completed mapping several hundred codes that are used in the Charlson and Elixhauser comorbidity indices. And we are currently working on validation of those codes for the Charlson mappings. And throughout our mapping work, like we did for the SMA study, our approach has been to use a combination of automatic mapping and manual review, along with custom mapping when we get to codes that are Canadian specific. We leverage whenever possible the ICD and drug-related mappings that are in Athena. And to date, our group has mapped or reviewed around 5,200 ICD-10-CA codes. And that's out of about 16,000 ICD-10-CA codes. That's including codes that have been retired over time, but may still be in some of our older data. 2,700 ICD-9 codes, 4,200 ICD-9-CM codes. And for ICD-9-CM, even these are in Athena, so we didn't necessarily have to map those, but we did review those alongside our other work because we were finding some issues with some of them. And so we provided feedback to Odyssey to improve some of those mappings. And then we also mapped about 635 drug codes at the DIN level. So the pilot project in vocabulary mapping is a significant effort toward implementing a pan-Canadian OMOP common data model, but much more needs to be done before OMOP can be used broadly across HDRN. We need to identify the feasibility for other HDRN sites to adopt OMOP and to start onboarding new sites that are interested and able to start participating, including OMOP information and training for analysts, as well as for relevant departments like IT and legal and privacy to see, you know, what their barriers are, what their needs are, and what sort of information they need to make decisions about whether they can participate. We need to start converting more core data assets to OMOP. So we haven't touched the emergency data yet. There's also physician services, billings information, which can vary by province because each province has different fee codes that they use. Labs and other commonly used data we might want to consider putting in, like mother baby cohorts and other registry information. Of course, we also need to map other Canadian terminologies, and one of the big ones are procedure codes like CCI, which can be rather complicated. Even CIHI is having challenges converting between CCI and SNOMED for some of their work. So hopefully we can work together with them to maybe speed up that process. And then finally, we're also looking into potentially doing another replication project involving Sentinel or CNODES. We want to basically replicate a larger, more complicated study to fully test out OMOP performance. And this could also give us an opportunity to explore more of the standard software that Odyssey provides and maybe compare that to some of the tools that Sentinel also comes with. So that would be sort of a secondary objective of doing that sort of project. And then recently, I'll just mention that HDRN Canada organized the first ever Pan-Canadian OMOP CDM engagement event in Toronto. That was in November. This event brought together organizations from across Canada that are implementing or planning to implement or exploring the idea of implementing OMOP, and laid the foundation for an Odyssey Canada chapter, which we hope will be launched very soon. Some of the key takeaways from that event were that OMOP adoption in Canada is more advanced than we actually thought. We identified about 11 organizations that had functional or almost functional OMOP CDM instances. However, fragmentation is resulting in avoidable duplication and some inefficiencies. So especially when it comes to mapping Canadian classifications, different organizations have done this work, and we don't know how consistent we're being with each other and what sort of effect that could have on results if we're trying to work with each other. There is strong support in Canada and in the larger Odyssey community for establishing a Canadian Odyssey chapter. And we came up with a consensus on a couple of priorities for the chapter. So launching a small number of early multi-site demonstration projects using existing OMOP instances that are already out there at these organizations. And then number two, establishing a central repository to share mappings and any related documentation. And so these are things that we're either actively working on or considering at the moment. And as I mentioned, Odyssey Canada will hopefully soon be launched. The goal will be to advance adoption of OMOP in tools across the Canadian health research institutions, and also to share knowledge, align standards, and develop resources, and collaborate to enable multi-site observational studies, not just in Canada, but internationally, because there's a lot of interest in looking internationally as well. And so that is what we're looking for in the near future. And I think that is all for me. I want to acknowledge some of the funding that we got from Canada's Drug Agency, the different sites that participated in the pilot, IQVIA and EPAM, who were our subject matter experts when it came to OMOP. They are invaluable for helping us through this process. And then all the members that are part of the OMOP working group that have contributed to either the initial pilot or the vocabulary work that we did most recently.